Is a NASA computer really that good at playing demanding video games? Like, does it allow you to smoothly blow up a million TNT in Minecraft? Well, actually, it doesn't. First of all, the term NASA computer is a bit ambiguous. NASA doesn't design or manufacture computers, they outsource everything. They have done so since the beginning, but still, let's see if the quote unquote NASA computers are up for high end gaming. Firstly, the computers that actually go to space are immediately out for gaming because they don't need graphics cards because they don't have displays. Well, mostly. But besides that, the processors that are in space are not the latest and greatest high end chips because radiation wreaks havoc on modern processors. Whether it be from the sun or outside the solar system, radiation can go through processors and corrupt the data in them or even damage them permanently. The latest gen chips are being made in the 3 nanometer manufacturing process, which means the smallest component of a processor is only 3 nanometers across. The smaller size means less energy is needed for each individual transistor to work, which is a good thing, yes, so that processors with billions of transistors aren't using an ungodly amount of power. But for use in space, that means radiation can hit a processor and change the state of transistors more easily since not much energy is required. So, for usage in space, processors are usually made in an older processing node, which are at best 150 nanometers. Which means that while the latest gaming processor has more than 10 billion transistors, the RAD 750 computer that is on the Perseverance rover and the JWST telescope has only 10 million transistors, literally 1,000 times less. But still, the RAD 750 is not that shabby since the Gecko microprocessor is using a similar architecture. And if you are wondering what the hell the Gecko processor is, it is the processor used on the Nintendo GameCube. Yeah, you heard that right. The Mars rover and the $10 billion most advanced space telescope ever made is running on a similar architecture to the freaking GameCube. But do note that the GameCube is actually more powerful since it runs at twice the CPU speed and includes a flipper graphics processor. Though not all space processors are like that, some commercial companies have taken to using multiple redundant regular CPUs with shielding, and if the satellite is in low Earth orbit, then the Earth's magnetic field protects the satellite from radiation somewhat. NASA isn't that opposed to it either. Due to weight constraints, the Ingenuity helicopter uses an old Android smartphone processor for image processing, though it still has a separate radiation hardened flight computer, and it worked great. But these processors aren't beating commercial products anytime soon. And this gets to the heart of the problem with gaming on NASA computers, which is that NASA doesn't really need that much processing power. Like the computers on NASA mission control centers, there are a lot of them, are probably not that powerful. Usually they use regular pre-built computers running custom software and operating systems. That is not to say that NASA doesn't use latest gen high-end PCs, it's just that these PCs are something that anyone can buy and NASA has nothing to do with manufacturing or designing them. And why would they? Computers are used in every field these days, and companies like Intel, AMD, and Nvidia spend way more money on research and development yearly than NASA's entire yearly budget. But it wasn't always this way. NASA once contracted MIT's Instrumentation Laboratory, now known as Draper Lab, to develop the Apollo guidance computer for the Lunar Excursion Module, that is, the Lunar Lander, and the Command and Service Module. And they needed cutting edge tech to make that happen since there was no other options. They needed integrated circuits, which is the concept of putting all the components needed for a CPU on a single piece of silicon, which was only invented in 1960, and 7 years later, there were humans flying on space vehicles controlled by this technology. And at the time in 1967, there was no way a regular person would have been able to get a hold of one of these. But that changed quickly. By the time the last Apollo guidance computer flew in 1975, they were already outdated. And in the late 70s, the release of commercial computers like the Apple II already surpassed the Apollo guidance computer. Nowadays, NASA just buys pre-built PCs through government procurement processes. So the semiconductor companies must have insane processors that they sell to NASA, right? Again, sadly, no. For example, let's take the RTX 4090. the best GPU currently available for PC gamers. It is using a chip called the AD102, and if you didn't know, chip manufacturers usually use the same chip for multiple tiers of products. Cause let's say that you have a chip that has a defect in some part of it. This is rare but happens. And in a GPU there are thousands of identical cores, so you can just turn off the part of the GPU that is malfunctioning and still sell it as a lower tier product. In that way, the aforementioned AD102 processor is being used in all of these GPUs, ranging from the RTX 4070 Ti Super to the unreleased RTX 4090 Ti. And the best of them is the RTX 6000 Ada workstation card. This is the full AD102 chip with very few defects or cores turned off. This card, aptly to its name, costs $6,800 and has more RAM, support for enterprise software, and you can even have multiple of these GPUs in the same PC. But still, the RTX 4090 is better at gaming because though it has fewer cores, Nvidia is pushing it harder for gamers. It runs at a maximum of 450 watts, whereas the RTX 6000 runs at only 300 watts, since they want it to be more stable. So a better GPU is a must. There is no GPU faster than the RTX 4090 for gaming. Now what about the CPU? A game's performance is based on the CPU and the GPU together. Some games depend on one more than the other, but you still need a good CPU. And there are lots of crazy CPUs. For example, AMD's workstation CPUs have chips with 96 cores, and their big bag server processors have a whopping 192 cores and 384 threads. So are these CPUs going to improve my gaming performance at all? Sadly, like every answer in this video, it's a big old no. The reason for this is that games are usually running on few cores or even a single core. Even in this day and age where people at least have a 4 core and most people have a 6 core. So the reason that games don't run on multiple cores is not usually because the devs are lazy or anything. It's just because it's hard to code like that. Fundamentally, a game is something that reacts to your input, so every few milliseconds your input on the keyboard and mouse is being read by the game and the game world has to change accordingly. This needs to happen super fast so that you don't feel any delay. But a high core count CPU is perfect for a scenario in which each core does a job independently. So you can give each core a job that it works on for however long it takes, and finally it can store the result somewhere. So you need a job that multiple cores can work on separately. But nothing about a game is separate. As in, when you press the jump button, for example, it affects your character animation on screen, it affects the height of the camera, it affects the enemy AI which needs to find new ways to shoot you properly. It affects the entire physics calculation. What if you hit your head and fall down? What if you take fall damage from that? So everything is tightly knotted together in a game, and though you could optimize it by using multiple cores, sometimes it's just not worth the effort. So most game devs don't code games to be able to use many cores, and since the average gamer doesn't have 192 cores, no one codes games to be able to run on hundreds of cores. In fact, if you run a game on one of these CPUs, it will actually run slower than the best gaming CPU because the best gaming CPUs run at 5 GHz or more, whereas each core in the 7995WX has to clock slower so that it doesn't overheat the processor when all of them run at high frequencies. So once again, the best gaming CPU is the newly released $480 Ryzen 9800X3D, not some mythical CPU that only NASA can use. So now, is all hope of gaming on a NASA computer lost? Yeah, I told you at the start of the video, it's lost. But NASA computer actually refers to another thing as well, supercomputers. In fact, NASA has the 90th best supercomputer in the world, the Pleiades supercomputer at the Ames Research Center in California. NASA uses supercomputers for everything from simulation of weather, simulation of rocket launches, aerodynamic simulations for planes, basically a lot of simulations. But these supercomputers don't have exotic processors either. They are just mini server processors on multiple individual PCs on racks in warehouses linked together with super fast network connections. They run into the same problem of too many cooks. Like, yeah, the problem is bad when there are 192 cores. But what about 228,572 cores spread out over 10,410 separate PCs called nodes in a supercomputer arranged in 152 racks? It makes the latency problem a whole lot worse. A similar problem also happens on the GPU side. In the 2000s, there were ways to use multiple GPUs in a single PC with NVIDIA SLI or AMD Crossfire, but these have since been discontinued because the communication speed required for modern gaming is very high. So, a supercomputer with multiple different GPUs on different racks isn't really conducive for a good gaming experience. Like if you split up your screen so that different GPUs work on different parts, the time it takes to send the current state of all the elements on screen to multiple different GPUs and the time it takes to get the resulting frame back and assemble it all together and do post processing is a long time. So it's not hard to see why that might be difficult. But having said all that, the connection latency of these supercomputers isn't too far off from the last multi-GPU capable graphics card. Two RTX 3090 Ti's can be connected using the NVLink connector, which is capable of 100 to 150 nanoseconds of latency, whereas the InfiniBand HDR connections on these supercomputers have a vaguely less than 500 nanosecond latency. But still, literally zero games are optimized for supercomputers because literally zero gamers have supercomputers. That isn't going to change anytime soon unless some billionaire wants to spend a few $1 billion to develop a game specifically made for a supercomputer. But until then, us plebs only need a $1,600 GPU and a $500 CPU to have the best gaming experience, for now at least. Thanks for watching my video. This was my first and I chose this topic because it is right in the middle of all my interests: gaming, programming and space. So stick around for more videos when I get around to them, which might be 2 weeks or 2 months. And again, thanks for watching. See ya!